Driving the road to a greener and sustainable future will be a new generation of extended-range, heavy-duty electrified vehicles. ORCA, optimized, real-world, cost-competitive modular hybrid architecture, is a €10 million project that combines research, development and demonstration focused on accelerating the introduction of electrified hybrid heavy-duty vehicles. Such an ambitious goal can only be achieved by the collective knowledge and expertise of research institutions and industrial partners working together on new solutions. Like the interplay of different instruments in an orchestra to create a symphony of synergy, conducted by TNO and co-funded by the European Commission.
CINEA is the Climate Infrastructure and Environment Executive Agency of the European Commission. We are responsible for implementing parts of the EU funding programs which are related to transport, energy, climate action and environment.
The ORCA project aims to develop a modular and scalable powertrain design methodology for highly electrified hybrid HD vehicles with increased functionalities that include an improved electrified powertrain and plug-in hybrid electric vehicle capabilities, a longer zero-emission electric range of up to 30 kilometers for urban operations, a lower total cost of ownership, and emission levels below Euro 6. Here in Sweden, successful static load and dynamic testing of the ORCA truck by Volvo in April and May produced high-quality data to correlate the complete vehicle models generated earlier. The next step is to calibrate and correlate the simulation models with this data.
Volvo contribution is basically the prototype and the use case around that, which is a distribution truck that is also used to go to the city center where you can have zero emission zones placed there. It's also about the control of the hybrid around all the systems in the truck and these contribution with the partners on this co-design methodology to be able to size the powertrain in a cost-effective way. So we had performed extensive testing at Volvo at the Vehicle Feature Lab, VFL, here in the Volvo premises. And here we actually put the truck in the roller chassis dyno, and we did a whole range of big tests with the truck, which are quite good for us to validate the simulation models.
The Volvo topology has focused on the E-axle to create a compact, cost-attractive electric drive solution for battery electric vehicles and hybrid applications. In this approach, the electric motor, power electronics and transmission are combined in a compact unit directly powering the vehicle's axle. This makes the electric drive less complex and the powertrain cheaper, more compact and more efficient. In Italy, the energy storage system and the onboard charger, both designed and supplied by project partners, have been installed in the Iveco multi-modular hybrid urban bus demonstrator. Testing focuses on energy storage and the charger, static loads to identify multimodal system performance, and industry-standard sort tests to determine electric range, energy consumption and emissions.
If you look at the vehicle, there is almost nothing from a mechanical and electronic point of view which has been not designed on purpose for this project. We designed the full concept, the full architecture. We designed the system. The full transfer path of the torque has been designed from scratch. So the system that is taking the electric energy from e-motors and getting back to wheels, that has been done with a proprietary patent. That is one of the core, and that has been applied, invented and designed. Beside this one, all the controls that are managing the power flow has been sketched, conceptualized and made completely from zero. And that has been not only designed, but also the software that implementing it has been really developed and tested.
Iveco, together with its ORCA partners, completely redefined and optimized the bus's multimodal system architecture to meet ORCA's goals. The entire system had to connect seamlessly to guarantee the end result. The bus topology consists of 7 main modules, in which each component is crucial. At Iveco, parts like the DC-DC converter and onboard charger, developed by Valeo for commercial vehicle applications, have been central to the development of a converter based on an innovative topology that enables a platforming concept and standardization.
We developed a new DC-DC converter in order to fit with a 24-volt network of trucks and bus application. And the second application we developed in ORCA is an onboard charger, able to recharge more rapidly the vehicle. We were able to start with new concepts in this project, to be able to prove it, to demonstrate it on the table, and then after that to be able to integrate it in a real application, in a real bus who works on the road. So it was really, really good.
Blueways supplied lithium-ion capacitor cells, along with technical support, to facilitate the pack build, perform additional experiments where relevant, and analyze test bench results and field operation results. And the energy storage system developed by Blueways is, of course, a key component.
Our contribution to the project is the design, the production and the testing of the energy storage system, which is a crucial component. We delivered the lithium-ion capacitor to the University of Brussels for further simulation and characterization. We delivered the battery to be constructed on the bus.
Together with VUB, Blueways has selected and sized the RES system, including an innovative power buffer, the energy storage system, housing, cooling system, electric system, and battery management systems.
In ORCA Project, as a partner, as a VUB, we have worked on the selection of a suitable energy storage system. We have tested the batteries. We have developed an advanced simulation platform where we have evaluated the vehicle performance and compared it with the conventional IC engine performance, where we have shared our knowledge with our partners. Iveco, they have used it in their bus, and then Volvo, they have used it in their truck, and they use the knowledge to develop the simulation platform.
Since hybrid vehicles run on both electricity and liquid fuel, the key to lower emissions is to optimize the charging cycle for a vehicle by usage.
The system that we have studied have been particular waste heat recovery system, turbo compound, which is a device able to recover the kinetic energy of the exhaust of the engine and to transform it into electricity. And the other one is a heat storage device, which is designed in order to increase the cabin heating in cold ambient conditions.
CRF and Fraunhofer have contributed valuable expertise in waste heat and thermal system innovations.
In the ORCA project, we developed a part of a full vehicle simulation model to analyze emissions and the usage of energy of vehicle. Yes, it was a very nice cooperation with a lot of international partners, so we could exchange information and discuss the results in a very trustful and constructive manner.
TNO has years of relevant research and is applying knowledge of such systems as well as knowledge of city-level logistics models and battery optimization in the ORCA project. Furthermore, TNO's research facilities on sustainable mobility play an important role in R&D projects and programs and facilitate the orchestration of innovation, which is so central to the success of the ORCA initiative.
We have a lot of knowledge about engineering of powertrains and energy management of heavy-duty vehicles and components. Based on that knowledge, advanced computer modeling and the drive cycle of the vehicle, we can optimize and validate the powertrain and the vehicle's energy consumption.
We innovate for sustainable traffic and transport, and our goal is no more than zero emission.
The ORCA project produced valuable learning for future development.
The target of this is not to make the prototype, is to get through the full learning phase, which is including also experiencing by mistake. Research is also where you can challenge a bit yourself, try something that maybe you need not to try when you're going to production, and to raise the bar.
For sure we have learned a lot from it, and we already see a lot of what we have learned in the products today, and we are using it in our work for sure.
Within the ORCA project, Bosch together with Iveco and Volvo defined detailed requirements for future hybrid drivetrains for buses and heavy-duty distributor trucks. The results have been deepening understanding of future OEM requirements for Bosch and all partners significantly, and helps to speed up future electrification projects.
So the key outcome that is going to bring, but actually which is already applied in some of what we are doing as Iveco in the current electrification roadmap, is exactly this one.
The economic and environmental assessments of June 2021 show that ORCA vehicles perform better than their diesel counterparts from a TCO perspective. And the high fuel efficiency means that both the ORCA bus and truck perform better than a standard diesel equivalent.
The project, it's a learning, and you learn if you do open innovation, if you do cooperation with partners. You cannot learn if you're not open-minded. You challenge each other to see what is the capability and the knowledge on each of the parties. And at the end, the outcome is not an Iveco project only, it's the outcome of the overall consortium.
The power of ORCA is the close cooperation between industry and research institutions. In our international team, the research is always focused in bringing innovation into application.
I think it was really the team effort that we had to put this prototype together. It was much more challenging than we have expected in the beginning of the project. Took a lot more time, so I'm really proud of what we accomplished so far.
We were able in ORCA to develop new concepts, but also to make it happen, and then to integrate it also in a real application, in a real bus.
What we have learned in ORCA project can be directly applied in many of the products we have today, not necessarily as a plug-in hybrid, but also on the battery electric vehicles and many other concepts. So both the control and also the methodologies that we have developed for sizing are quite used already today in other projects.
Some of the technology that has been studied and invented and applied within the ORCA has been already implemented. Actually, we're not talking about mid-term future, but we're talking about something that is going to come to the customer and to the serious production in something around 1 year.
In ORCA, we see a chance for the future. So we see that we can manage climate change and develop cost-effective and low-emission transport.
So ORCA will really work as a pioneer of the projects that will be upcoming, and they will really help the next generation fleet to be electrified.
In the end, the ORCA project is doing exactly as it was conceived from the concept.
The affordable key innovations achieved will significantly boost European engineering and technological leadership in hybridized vehicles and give the European heavy-duty road vehicle value chain a competitive edge. Finally, the ORCA optimization framework and approach will enable future vehicle designers to realize cost-optimal powertrain designs. ORCA technologies will be ready for market in 2022 and beyond.